4.5, graphing other trigonometric functions. So in 4.4, we graphed sine and cosine functions, and now we're going to look at tangent as well as all of the reciprocal functions. So we'll also look at cotangent, cosecant, and secant. So looking at the tangent function, we're going to go back to making a table. So this time we're going to go from 0 to pi. It's a little bit different. So first we're going to start out with y equaling the tangent of 0. Let me get my marker here. There we go. And we remember tangent is a combination of x and y. Tangent is going to be y over x on my unit circle. And so here is my 0. And at that ordered pair at 0 degrees or 0 radians is the ordered pair 1, 0. So x is 1, y is 0. And so when I do my tangent of 0 is my y over x, which is 0 over 1. So my tangent of 0 equals 0. And so that means if y is my tangent of 0, then y equals 0. So I'm going to go back up and put a 0 in here. So now I'm going to do y equals tangent of pi over 4. So pi over 4 would be like a 45-degree angle. So I am going to draw a triangle. I guess I should really label that pi over 4 instead of 45. So pi over 4. So 45 would be 1 square root of 2. Right angle, my tangent, of course, is my y over x. So my tangent of pi over 4 is 1 over 1 or 1, and so y equals 1. Now I have tangent pi over 2. And so pi over 2 would be a point on the unit circle again. It's the point 0, 1. And when I am doing the tangent of pi over 2, it's going to be my y over my x, so 1 over 0, which is undefined. And since the tangent is undefined at pi over 2, it's going to just be undefined here. So I'm going to write down undefined, and that means we're going to have an asymptote. So kind of making that connection between we can't actually equal that x value, and then there'll be an asymptote there. All right, so 3 pi over 4. So 3 pi over 4. So that's going to be over here. So that means inside I'll have pi over 4. 3 pi over 4 plus another pi over 4 would be the 4 pi over 4, which is my 180, which is like my line. And so now I'm going to have 1 square root of 2, but this is a negative 1. So my y over my x now is 1 over negative 1. Which equals negative 1. So then I'm going to write y equals negative 1 and go up to my table and put that down. And now we're down to pi. So unit circle again. And this point is at negative 1, 0. And if my tangent is my y over my x, then the tangent of pi is 0 over negative 1, which just equals 0. So I'm kind of back to that value that I started with, and we've done a complete period. So the period here is going to be pi. So the graph on this one's really weird because of the asymptote. So I'm going to go ahead and draw in my asymptote right now at pi over 2. It starts at 0, 0, and then at pi over 4, it's up 1. And then at 3 pi over 4, I have negative 1, and I'm at 0 again. So this is this whole period that's going to repeat. But I think it's really hard just looking at this to get a feel for this function when we are just looking at these two pieces that are like this. So I know if I'm going to repeat this, then after my blue over here, I could do this part again and another asymptote. So I'm repeating this part. And then it would be this part again. And then I'm even going to do one on the other side over here. So normally when I graph tangent, I know that they say the period is from 0 to pi, but a lot of times this is what I graph. I like to graph this part with the asymptote on both sides because I think it's easier. So this is what I graph. So while you could graph from 0 to pi, I'm telling you it's just going to be a lot easier if you do it my way. So the period is pi this time. My asymptotes are at multiples of pi over 2, 3 pi over 2, so odd multiples of pi over 2. And my amplitude, and notice there's quotes about this because it's not really amplitude, it's kind of, sort of, would be like the 1 and the -1 still. Really what we call those now is halfway points. So it's a halfway point because halfway between the 0 and the asymptote, I'm at 1. Halfway between the 0 and the asymptote, I'm at -1. So my halfway points are -1 and 1. And that's because they're located halfway between the 0 and the asymptote. So let's maybe add a note of that somewhere. Halfway between 0 and the asymptote. So at the halfway points, I have -1 and 1. So it's not really amplitude now, it's halfway points instead. But a lot of times I'll talk about how it's amplitude-like, and just kind of do air quotes on it when I'm talking about it, and we'll write down 1. So really they're the halfway points though. So lots of weird stuff going on with the tangent graph. So let's go ahead and try one. If I have this 2 in front, I know that is a vertical stretch by 2. Because I'm outside the function, I'm affecting the y. And the part that's inside with the x is going to affect the x, but it always does the inverse. So instead of dividing and shrinking this down by a factor of half, it's actually going to be a horizontal stretch by 2. So just like before, because I'm stretching vertical, that's going to affect my halfway points. So I could say amplitude in quotes, or I could say halfway points. You can see why we keep writing amplitude, because it's just faster, even though it's kind of lazy and wrong. So our halfway points are now -2 and 2. And my period is now 2 times pi. So cosine and sine, again, are already 2 pi. The period of tangent is just pi, but I'm doubling it because this time I have x over 2, which means I really multiply by 2. And so my period is going to be 2 pi. So when I graph this, remember it's centered around the origin. So I'm going to graph it around the origin, and I'm going to have this line at normally pi over 2 and at negative pi over 2. And we've got the 0, and then we've got those halfway points. So that's what we've got going on. So if our period is 2 pi, that means we're going to have still something at 0, and half of my function is going to be this side, half my function's on the other side, but now it's going to go from negative pi to positive pi. So when I look at graphing it around the origin, that's why I think it's so much easier. I can just basically take whatever that period is and divide by 2, and that's where those asymptotes are going to go, and that gets me a start. So now I'm going to go back up and actually graph, and I'm going to switch colors because I don't like the way the red looks. It's really harsh. I need my scale to go up to 2 and -2 for y. Okay, and now I'm going to make my graph go to pi and negative pi. And then I'm going to mark down a 2 pi and a 3 pi. We're always trying to make 2 periods. So if the period's 2 pi from negative pi to pi, that'll be 1 period. From pi to 3 pi will be another period of this because my period is now 2 pi. So I know that I've already figured out my asymptotes are going to go at pi and at negative pi. And then I'll have one over here at 3 pi, so I'm just continuing that pattern. My zeros are always going to be halfway between those two asymptotes. So I'll have a 0 at 0, I'll have a 0 at 2 pi. So the halfway points are halfway between the 0 and the asymptote. So here's my 0, here's my asymptote. So halfway in between them would be pi over 2. And this one will be up to 2. And then halfway between these two is negative pi over 2. And that one will be at negative 2. So our tangent function is always going up. And then halfway between these guys, let's see, pi over 2, 2 pi over 2, this would be 3 pi over 2. 2 pi is really 4 pi over 2, 5 pi over 2. So halfway between the line, my asymptote, and my 0 would be that negative 2. Halfway between the 0 and this asymptote is the point at positive 2, so my tangent line is going up still. And we've graphed 2 periods. So it's kind of weird with those asymptotes. But I think once you know the shape, it's going to follow the stretching and shrinking stuff just like everything else we've done. We're going to look at another tangent graph, and then we will look at all 3 reciprocal functions, and we'll just graph the parent functions for those. So when I'm graphing this tangent, my halfway points are going to be -1 and 1. And again, I could say amplitude in air quotes, but it's not really amplitude. So my halfway points, if I multiplied something in front, it would vertically stretch it and stretch out those halfway points. But I don't have that on this one, 1 and -1. My period x is not being multiplied by anything, so my period is still 2 pi. I don't have a vertical shift, but I do have a phase shift. Oh, sorry, my period is pi on this one. So again, cosine and sine are 2 pi, and tangent is just pi. Let's see, so my phase shift this time is a negative pi over 4. Phase shifts, anything when we do stuff with x is always going to be inverse, so instead of adding and moving in the positive direction, we subtract. So my phase shift is negative pi over 4. So let's think about our graph again. We're normally centered around this origin with a line at pi over 2 and a line at negative pi over 2. But I'm going to have to shift both of these lines. I'm going to have to shift the 0. Everything's going to go negative pi over 4 units, even the 0. So I want to think about how that's going to affect my graph over here. So all we're doing is that phase shift, so at least it's not like 50 different things we're changing at the same time. Okay, so here's my y-axis. Here's my x. This will be my 1 and my -1. So if my asymptote was at pi over 2, now it's going to be at pi over 4. Because I need to move everything pi over 4 to the left. So if I normally had a 0 at 0, now it's going to be at negative pi over 4. And then normally at pi over 2, I'm going to have to move this one right here. Normally at negative pi over 2, I would have my line, but that's been shifted a quarter unit the other way. And so that's going to be at, I'm going to have to extend this, -3/4 pi. So now my line's over here. So once I've got those asymptotes, I know halfway between them was the 0. And then halfway between the asymptote and the line, I would be at -1. I almost feel like it'll be better if I graph it in a different color. And then halfway between the 0 and this asymptote on the right is going to be the +1. And then I connect it. And then I just want to make another period of this graph of this function. So pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. So if I take that pi over 4 and I add pi, I add a whole period. Now I'm over here. So this is going to be another asymptote. And now I'm going to use symmetry again. So halfway between my two asymptotes is my 0. Halfway between my asymptote and that 0 is going to be my -1. Halfway between the 0 and the right asymptote is going to be the +1. And then I'm going to connect again. So now we had a graph with a phase shift of -pi over 4. So now we're going to go ahead and look at reciprocal functions. So cotangent is kind of interesting. If you think about anywhere, like normally on my tangent, I have a 0 at 0. Well, the reciprocal of 0 is undefined. So I would have an asymptote here. My next 0 would be at pi, and reciprocal of that would be undefined. So I'm going to have another asymptote. So basically anywhere I had zeros, now I have asymptotes. Anywhere I had an asymptote, I now have a 0. So I've got one here, and I've got one here, and what the heck, we'll put one over here. This is supposed to be the actual period on this one. My period is pi still. So now my asymptotes are at multiples of pi. This is almost a little bit easier. My amplitude is 1, but it's not really amplitude, hence the quotes. It's really these halfway points, which are at 1 and -1. And the order is going to kind of flip here. So if we think about what was going on with tangent, at pi over 4, I had a 1, and now it's going to be down here at -1 instead, and like this. So, oh, sorry. That's the same direction as tangent. This is going to go the opposite direction. So here, here. So my cotangent's going to start up, and it's going to go down. And same thing on this side. So it looks an awful lot like tangent, but kind of shifted, almost easier to graph. So tangent's going up, cotangent's going down, and then this one's going from 0 to pi instead of -pi over 2 to +pi over 2. So a little bit different. So for secant, I am going to first graph my cosine, reciprocal of cosine. So cosine, remember, is up, middle, down, middle, up. So it's going like this, and it goes from 0 to 2 pi. So the period here is still 2 pi. Amplitude, we put in quotes again, is still going to be 1. And we have some asymptotes, so hang on and wait for that. So up, middle, down, middle, up, all the way from 0 to 2 pi. It's a lot easier if you pre-printed the graph stuff here, but if you didn't, it'll still work. It'll just take you longer to graph. Okay, so here's my function. Here's my cosine of x. So now I'm going to think about what happens when I flip this. Well, anywhere I had a 0, when I do, and 0 I mean like the y is equal to 0, when I take the reciprocal of that, I'm going to get something undefined. So I'm now going to have all of these asymptotes. So you can see how we graph the cosine first, and then anywhere I have a 0, I draw an asymptote. And so those asymptotes are going to be at odd multiples of pi over 2. So like pi over 2, 2 pi over 2 is just 1 pi, so it's not there. 3 pi over 2, that's an odd multiple. 4 pi over 2, that's an even. That one isn't again. So this is going to be odd. My pen went kind of funny there. Odd multiples of pi over 2. So that'd be like negative 1 pi over 2, 1 pi over 2, 3 pi over 2, 5 pi over 2. So like 1, 3, 5, those are our odd numbers. And then the second part of this is it's like we're doing the reciprocal, so it's kind of like we're flipping the graph. So this humpy part here is now going to flip, and it's going to go like this. And then this humpy part that's down here is going to flip and go like this. So a teacher that I really love and respect calls this flipping the humpies and then writing the asymptotes, which just sounds kind of dirty, but it really works because you're taking this hump part and you're flipping it, and then you're following those asymptotes up or you're following them down. So that's how we're going to be graphing a secant. So whatever the function is, if it says secant 2x, you're going to graph cosine 2x. And then you're going to transform that you're going to transform that graph. So first you're going to graph the related reciprocal function, and then you're going to just do the flipping and the asymptotes part. Cosecant is very similar. We're going to do the same thing. We're always going to graph the related sine function. So you're going to first graph y equals sine x. So if this was 4 cosecant x, you'd be graphing 4 sine x. If it was cosecant x plus 3, you'd be graphing sine x plus 3. So you're going to always graph that related reciprocal function, and then you're going to create your asymptotes, and then you're going to flip the humpies, and then you're going to write the asymptotes. So when I graph my sine of x, that's middle, up, middle, down, middle. So that one looks like this: middle, up, middle, down, middle. And it goes from 0 to 2 pi. So here's my 0, here's my 2 pi. Halfway between is another 0. This is up, this one's down. So I can just keep graphing these. And then everywhere I have a 0, I am making an asymptote. So now our asymptotes are at multiples of pi. So let's see, period is 2 pi. Asymptotes are multiples of pi. And our amplitude, it's not really an amplitude, but we do need to know 1 because we're really doing the sine function first. So now once we have all that set up, once we graph our related reciprocal function and put our asymptotes in, now you're going to flip the humpies and write the asymptotes. And then the part in blue is actually the part that is my cosecant. So this blue part is my cosecant of x. The red one, of course, is my sine. The graphing really takes a lot of practice. I've worked hard to put worksheets into Canvas for you. I just thought maybe this year that would be better than bookwork. I think with the worksheets, you really get a sense of what we're doing. The book assignments, sometimes it's like you never get quite enough practice at one thing before they make it really difficult. So we do have worksheets, and please ask questions in class as you need them.